Okay, so now you understand what's meant with the cursor of dimensionality. Yeah, we have this high dimensional vector space, and in there, each word has the exact same distance to all the other words. So there is really not any way in this vector space to differentiate between these different words. Now, a cat has the same distance from a dog as it has from the house, even though you would expect that animals as concepts semantically should have a different distance from a house, which is a human-made artifact. So if we want to be able to build AIs, intelligent systems that understand the meaning of words, we need better word vectors that have a better representation of the meaning of the words they capture. So there are two steps towards this. First, one problem is that this is very high dimensional, and most of the dimensions are zero. Now in one hot, there's only one value that is 1. So instead of working with this kind of one hot representation, we want to have a more dense vector, which has a much smaller number of dimensions and has a lot fewer zeros. And secondly, these vectors should capture the semantics of words, like how much is the word about animals or places or actions and so on. So in this kind of representation, the distance, for example, the cosine distance in a vector space between the cat and the dog should be a lot smaller than between the cat and the house. On the other hand, words that are different but have the same meaning should have basically identical word vectors, even though they're represented differently. In the one-hot representation, they would be just as different as cat and dog or dog and house. But in our semantic representation, because they mean the same thing, they should be identical or nearly identical. And now, if we have a representation like this, then we can use these word vectors to answer the type of analogy questions that we started out with today. Yeah, if you have a question like who is to physics what Louis Pasteur is to germs, then we can represent these word vectors here using these semantic vectors. So we have a vector of representing Louis Pasteur, we have a vector representing germs, and we have a vector representing physics. Now, if we take Louis Pasteur, we subtract the vector for germs, but add the vector for physics, then we should come to a vector in the vector space that represents another person. And this person should be to physics what Pasteur is to germs. So there is an exercise on the worksheet to try and reformulate the first question. And once you're done, we're going to look at how we can make this work in practice.